Hello everyone, I'm Mr. Alvin from ASUS Math, and today I will be guiding you through the functions question posted on our IG profile 2 days ago. If you haven't tried it already, do take some time to visit the question first in order to maximize your learning experience. Otherwise, we are all set and let's begin now. So this question is a question on composite function. Part A is to test you on the condition for a composite function to exist. So right here, we have the condition for a composite function to exist. And when faced with this, right, you always have to ask yourself this question in order to answer the existence of a composite function. Okay, so in this case, clearly the answer is no, as -1 is within the range of G, but -1 is not within the domain of F, and hence this composite function Fg does not exist. In fact, you need not use the value -1 solely. Any values within this range here will actually answer the question, because this interval of values are all within the range of G, but unfortunately absent from the domain of F. Okay, so with this, let's move on to part B. Part B is to test you on the construction of the range of a composite function GF. So in this case, we need not prove the existence of GF, but can dive in to calculate its range straight away. Constructing the range of a composite function is usually a two-step process, and the first step is to actually construct the range of the first function, in this case, fx. So to construct the range of fx, I can just simply substitute the endpoints in, f0, which will give me 0, and f square root pi would give me pi. And the range of f is just 0 to pi. Okay, notice that I can do this in this case by substituting the endpoints in directly to evaluate the range of f, right? Only because fx is a monotonic function, whose graph looks like this in this case. As a monotonic function, I can simply substitute the endpoints here and here, evaluate their corresponding y values, and the entire interval sandwiched by these two goalposts, right, will be the range of fx. So that covers the first step. So the next step, right, is in fact to ask this question. What will be the range of gx if its domain has been changed into the range of f, which is whatever the first function is feeding into the second function? So based on 0 to pi, right, how would sine x look like? Based on 0 to pi, the graph of sine x simply looks like this. Okay, let me just draw one full wavelet of sine x, and it actually looks like this. But based on 0 to pi, the graph will only be this guy right now. So based on this, what will be the updated range then? So the range is simply 0 to 1, the set of y values here. So the updated range of G is just 0 to 1, as compared to the previous interval, which was -1 to 1. Hence, this updated range of G is actually the range of GF. Alright? Notice one thing that I want to highlight is that, notice I did not simply substitute the endpoints 0 and pi into GX and declare that the interval is the range of G, because Gx in this case is not a monotonic function. If I simply substituted 0 to pi, right, and you might wrongly declare that the range of G is just the value 0 to 0, which is not true in this case. So please pay attention. This method that I used here only works when the function is a monotonic function. Otherwise, you should always establish the range of a function either graphically or you know its behavior very, very well. Alright? Alright guys, that's all from me today. If you found the session helpful, be sure to share with your friends and follow us for more videos. I see you all at the next session. Bye bye.